Welcome back for part 3 of unit rates involving ratios and fractions. That's going to be chapter 1, lesson 1. We are now on resource 7 of 10, so we're almost done. Josiah can jog 5/6 of a mile in 15 minutes. Find his average speed in miles per hour. Now, first thing it asks is, what do you notice about both of the quantities of the rate? Well, some things I notice, they have units. One is miles, one is minutes. I notice that the first quantity, 5/6, is a fraction. I notice that the second quantity, 15 minutes, could be written as a fraction because 15 minutes is 1/4 of an hour. And by knowing that, I could use it in order to easily come up with what his miles per hour is going to be. Moving forward, they show us several different ways to do this. The first option, they said, is to take and make a bar diagram. And you can see on the bar diagram, they have got it broken down. You've got 15 minutes, which is 1/4 of an hour. From there, you have got, the next option would be another fourth, another fourth, and another fourth. Likewise, your miles, you've got 5/6 of a mile, and each one of these would end up being 5/6 of a mile as well. On the top, because we use 4 1/4, that added up to a whole mile. The question is, what is this going to be? Now, there's two ways you could put that answer in. You could put it in as an improper fraction or as a mixed number, and the proper way that we learn to do fractions is that you can never leave it as an improper fraction. You always leave it as a mixed number. Now, you can see over here that they said because, kind of not highlighting very well, but let's highlight what we can. Because 4 times 5/6 is equal to 6/20, also known as 3 1/3, then the unit rate is going to be 3 1/3. So let's take and put our check mark there. We're going to type in our 3, create a fraction, 1/3, accept it, and check our answer, and our answer did check correctly. Now, we won't say that. Next method, use a double number line. You pause the recording and use a double number line to solve it. You should know how to do this by now. Pause it and then check your answers. Alright, so here we are, time for the double number line. What do we know? Well, first off, we know that 1/4 of an hour is equal to 5/6 of a mile. So then we've got 2/4 of an hour, 3/4 of an hour, and 1 whole hour. That means that 2/4 of an hour is going to equal to 10/6 of a mile, double 5/6. 3/4 of a mile will be 15/6 of an hour. And then the final one, 1 whole hour, is going to be 26 of a mile, which is the same 3 1/3 that we came up with the other way. So that is method number 2 for skinning this cat. We came up with 4 different methods in this lesson. Moving on to the third method is to use the ratio table. Now you take and look at this one. I'm not going to make you put it in because, dang it, they'll give you the answer right here. See, right there, they tell you what it is in miles per hour, and we've already done it several ways. For the ratio table, you took and multiplied the top and bottom by 4, and in the end, what are you going to plug in there? You're going to plug in your 3. Oh, let me get it highlighted. 3. Where's my fraction at? Fraction 1/3. Hit the accept button and check our answer, and it did check. This is an example of using your ratio table. And from here, the last one they have is the division method, which is the one I prefer. In the division method, look what they did. They took 5/6 of a mile and 1/4 of an hour and created the ugliest thinking problem we have seen yet. A fraction and a fraction and a fraction. So what are we going to do? Well, first off, we're going to rewrite it into something that makes sense. 5/6 divided by 1/4. From there, let's zoom in just a little bit so you can actually see these. From there, we're going to, scroll down, keep change flip. Whoa, I went way crazy on that. Keep change flip that you see right here. After we keep, change, flip, I would encourage you to simplify and then multiply. Here they did not simplify. They said 5 times 4 is 20 and 6 times 1 is 6. And now they've got something they still have to simplify. So to simplify that, you could divide by 2 over 2, which would give you 10/3. And then you would have to, of course, change it back into a mixed number for your final answer, which once again, how far can they jog in an hour? Same answer is going to go in here. 3 fraction 1 over 3. Except, check our answer. Oh no, what did I do wrong? Can jog. Oh, that one should be right. I wonder why they did listed as wrong. So let's try that one again. I'm curious now because that's the same answer we put in every other time. So let's take and try it instead as 20/3, just for curiosity here. So 20 over 3. See what they do with that. I'm curious now. Check it. That one came out wrong. Well, so 3 1/3. Isn't that what we said the first time? They said that's the right answer. Oh well. Moving on to our next slide. How could you word this problem in minutes instead of hours? Does it change the outcome of its average speed? Well, you could instead write it as, you'd have to calculate 60 minutes in an hour, but that would totally change the way it looks. But in the end, the speed itself would not change. Only the numbers representing that speed, because you'd be using a different unit. And our checks generally don't work. This one crashed as well. Let's move on to our 8th resource. Alright folks, this problem is totally on you. Pause the recording. You've got 4 choices on how to solve this problem. It's up to you to pick the one you want. Go ahead and knock it out. You need some help. I'm going to leave a little tip up here for the need help so that you can take and say, 10 minutes is the same as what? Think about it. I bet you can solve the problem. Pause your recording. So Aubrey can walk 2/3 a mile in 10 minutes. Well, the first thing I want to focus on is this 10 minutes here. How much of a mile is 10 minutes? How much of an hour is 10 minutes? And the answer to that is 1/6. Because if you were to say out of 10, you'd have 10 minutes out of 60 minutes in an hour, those zeros could divide each other out, basically dividing by 10 over 10, meaning that 10 minutes is 1/6 of an hour. And because of that, now we can take and figure out our answers. First thing to look at though is how we're going to set up our original problem. So we have 2/3 of a mile in 1/6 of an hour. Now something to be noted is we have gone from minutes at that point to hours, and that's going to give us our speed in miles per hour. We can rewrite that as 2 over 3 divided by 1 over 6. Next we're going to keep, change, flip. 2 over 3 times 6 over 1. We're going to simplify, which says 3 goes into 3 once, 3 goes into 6 2 times, and we can multiply, giving me 4 over 1 or just 4. So the answer is going to be 4 what? 4 miles per hour. I guess we need to add that into our answer as well. So with that, we can take and go back to our document. We're going to type in 4 miles per hour. Check our answer. Woohoo! We are doing good. Moving on to resource number 9. Now on the applies, you've got a lot going on here. You can see it says apply on the top, and when you see apply, you know we're getting close to the finish, but you also know you're fixing to do a whole lot of work. So, first off, Carolina and her friends are training separately for a kayaking competition. The average distance and time traveled is shown in the table. See, there's a table. If the distance kayaked in the competition is 3 miles, predict who will win based on the rate shown. Predict how long it will take the winner to complete the race if the rate remains constant. And here we've got some pretty funky numbers to work with. Now we're going to scroll down because we're going to have 3 different things going on. four different things. First off, what's the task? Make sure you understand exactly what the question is to answer or problem to solve. You may want to reread it 3 times. The first time, describe the context of the problem in your own words. The second time, what mathematics do you see in the problem? And the third time, what are you wondering about? Now, I want to take and highlight the couple things in here. I want to take and right there, that's the goal, that's the question we want to be able to do, is predict who is going to win. And we also need to note that if that we're basing this on a 3-mile competition. Now, from there, we can take and go down and say, 1, how can you approach this task? Well, we could take and, well, excuse me, I'm not going to answer that yet. I want you to pause the recording in a minute and answer that, and then we'll compare answers. Next, you're going to take and type in your solution, and then finally you can take and write an argument about why you think your solution is reasonable. So you pause the recording, do all of that, and then get back with me. I look forward to seeing what you put. Alright, we have a lot of work to do here. The first thing I wanted to fill in is my strategies I would use. First, I will calculate the average speed in miles per hour for each kayaker. That's the simplest way to find out the fastest speed. I don't have to know how quickly each one of them will get 3 miles. I just need to know who's the fastest. Next, I'm going to calculate how long it will take for that one kayaker to travel 3 miles, because I need to know who will win and how long it will take them to win. So from there, we're going to take and jump over to our scratch pad, and we're going to start working on it. Now, first one is going to be Caroline. So Caroline, let me get my pen going. Caroline is going to equal to 7/8 divided by 1/2, which we can rewrite as 7/8 divided by 1/2, also known as 7/8 times 2/1. We can simplify that down. 2 goes into 2 once, 2 goes into 8 4 times, and when you multiply that out, then we're going to get 7 times 1 is 7, 4 times 1 is 4, and that will end up being 1 3/4 miles per hour. And that didn't copyright, so let me do that again. 1 3/4 miles per hour. We're going to switch over to red for Leslie. So we got a nice L for Leslie here. Leslie is 1/1/3. That's also known as 1 divided by 1/3, which is also known as 1/1 times 3/1, or 3 miles per hour. So Leslie's definitely rocking up on how fast Caroline did. Now we're going to move on to our third one. That's going to be Brian. We'll make Brian blue. And Brian did 3/4 to over 3/4. From there, we can take and change that to be 3/4 divided by 3/4, also known as 3/4 times 4/3. Simplify before you multiply, and when you do that, all those numbers divide out, becoming 1/1 or just 1. So that means that Brian is the slowest kayaker so far. And our fourth one, Javier, we're going to take and put a J down for him. And Javier goes 1 mile in 2/3 of an hour. With that information, I can take and change it to be 1/1 divided by 2/3. That's the same thing as saying 1/1 times 3/2, which leads it to being 3/2, or 1 1/2 mile per hour. So currently it looks like Leslie is the rockin' dog here. Leslie's going to be the fastest person. So we're going to take and jump back over here, and we're going to plug Leslie in as our winner. And then how long will it take her to do that distance in hours if it remains constant? Well, let's go back, and we're going to go back to Leslie again. Now Leslie is traveling at 3 miles per hour. If you look at it, she did 1 mile in 1/3 hour. So let's do that. Let's take and rewrite her as 1 mile in 1/3 hour. Multiply that by 3/3, and when I do, that's going to give me 3 miles, which is the goal. That's the reason I chose 3 here. So 3 miles was a goal, and I'm going to uncircle that because we're not done. And then 3 times 1/3, that's going to end up giving me 1 hour. So she goes 3 miles in 1 hour, which means how long is it going to take her? It's going to take her 1 hour. So we're going to go here, plug in a 1, and check our answer, and woohoo, we got them both correct. Excellent. Now you can take and write an argument about why the method you used was the best, and how and why you believe your solution is right. We are on our last problem, and boy is it a doozy. It is very similar to the last one, where you're going to have to calculate what day Emma drove her bike the fastest on, and if she was able to ride her bike at that fastest speed for 15 miles, how long in minutes will it take her to complete the race. So you pause the recording and figure this one out. Be careful, hint hint, it's in minutes for that other answer. You need some help? There's a little help there you can use. They're suggesting finding the unit rate for each one. That's what I did last time. Found out how many miles per hour it was in each one. You all get started, and I look forward to seeing how many of you get it right. Alright, you can see where I have worked this out, and I've taken and set up each of my ratios. Monday, 14 miles in 7/9 of an hour. Now pay attention here, the 14 goes on the top, the 7/9 goes on the bottom, because you miles per hour, distance divided by time, okay? And that ended up making Monday truly her fastest day. So we go in, and Tuesday was her next fastest day, and Saturday and Sunday, well, she just about had to drag herself down the road on those days. She was going really slow. So you can see where on my answer document I've already selected Monday, and now we have to take and find out if the bike race is 15 miles, it will take Emma blank minutes to complete the race if she can maintain her fastest speed. We've got to come up with a good way to solve this one, and there's a lot of ideas on what we can do, and I think for this one either a double line graph or a ratio table will work. And I'm thinking I might just use a ratio table just because I don't like double line graphs. A ratio table just makes more sense to me. So let's go in here, and we're going to focus, well, that's not the one we wanted. We're going to focus on her speed of 18 miles per hour. And we got to go at 15 miles, not 18 miles. So I'm going to move my slate up here a little bit, and I'm going to say that she will go, we got her speed. Oop, we don't want that. Hold on. Let's call this distance instead. Distance is going to go on top, and time is going to go on the bottom. So with that said, we can take and say I'm going to go and make a 3-column table here, and in my middle column I'm going to say that, actually now in my last column I'm going to say that she will travel 18 miles in 60 minutes. Now I'm going to divide. I don't need to know how long it will take her to go 18 miles. I need to figure out how long it will take her to go 15 miles. So I need to come up with a common number that I can divide into all those and what I can get it down to. And the common goal is to get it down as a starting point of a distance of 3 miles. To get there, I'm going to divide 18 by 6, and I'm going to divide 60 by 6. Okay, we good so far? And 60 divided by 6 is going to be 10. But I don't need 3 miles, I need 15 miles. So what am I going to do to 3 to get it to equal to 15? I'm going to, let's change our color here, I'm going to multiply by 5. 3 times 5 is 15. Now she's done the 15 miles. And then I can say here, 10 times 5, that's going to become 50. So the answer we're looking for is going to be 50 minutes. We'll go back over to our thing, see if Mr. Reitz is right or if I just screwed everything up. Let's find out. Woohoo! I got both of my answers right. Now, you guys have a bunch of homework ahead of you. Make sure you're showing me good quality supporting work, folks. If you're not showing me good quality supporting work, I can't give you credit for it. You can't just throw down answers. If you just throw down answers, I'm going to give you a 0, kick it back to you, and make you do it over again. You gotta justify every single answer with good quality supporting work. I look forward to seeing lots of perfect 10s on this one.